flies from O at an initial speed of 200 meters per second with variable inclination alpha. Take G is 10. Find two possible angles the gun can be set so that it will hit a fortress 2 kilometers away on the top of a mountain 1,000 meters high. So we got this bit. So that's 2 kilometers away, which is 2,000 meters, and a height of 1,000 meters high. Okay, that's the diagram. So it hit a so like this, something like that, right? So the angle is alpha, which is not given. We have to work out what alpha is. So all the previous question angles are given. This one, the angle is not given. You have to work out alpha. So we have to set up the 6 equations of motion, and then we're going to solve for alpha. Okay, so the initial speed is 200 meters per second. And like before, we have to work out the value, the initial value of x and y, as well as x dot and y dot. That will help us to find, the c. Okay, so what you do is, it starts off with the 0, 0, right? And then you have to find x dot and y dot, and to do that, you just draw a triangle, which is alpha here, 200, with x dot here, y dot there, and you can just write down the vertical one is the 200 sine alpha, and the other, actually that will be cos alpha, and the other one is the 200 sine alpha. Okay, all right. So have this information there, and then we'll set up the 6 equation. Okay, all right. Have a try. So you started with x double dot is 0, and then you started y double dot equal to negative g, which is negative 10. G is 10. Right, and then just work your way through. Try to find x and x dot, y and x. Okay, have a try. Okay, all right, good. So I have this red drawn. So we continue. So okay, good. All right, let's do this. So we go x dot equals to 0 plus c. Now to find c when t is 0, x dot equal to 200 cos alpha. So you substitute. So therefore 200 cos alpha equal to 0 plus c, and c can be found. Okay, and then you update your formula. Therefore x dot must be equal to 200 cos alpha. Draw a box around it, and then this one, draw a box, so you have 6 equations. I will continue. Yeah, so we continue. So we're going to integrate this again. So x, now remember that's a constant. When you integrate, you get 200 cos alpha t. Okay, that's a constant. All right, you're not integrating cos, you integrate x dot. Get that plus c, and when t is 0, x is 0. Okay, so therefore c equal to 0. Okay, so x equal to 200 cos alpha t. Okay, another box. Alright, good. So you have these 3 equations, and then you do the same thing for y double dot. Okay. Alright, continuing. So do y dot equals to negative 10t plus c. When t is 0, y dot is 200 sine alpha, and then you can use it to find c. So you go 200 sine alpha equal to 0 plus c, so c equals to 200 sine alpha. So you get y dot equal to negative 10t plus 200 sine alpha. Up to a box around it. And then we continue, so we find y equals to negative 5t squared plus 200, remember it's a constant, that times by t plus c, okay? And like before, when t is 0, y is 0, therefore c is 0, okay? So you write down y equals to negative 5t squared plus 200 constant times t. Alright, so we got the sixth equation of motion, which we'll use them to answer the question. Okay, so you get 6 equations. Alright, so instead I'll give you a minute or two to complete the working. Alright. Yeah, okay, alright. Now, we're going to work out the angle alpha. So, to work out alpha, you have to use the Cartesian equation. So, let's derive the Cartesian equation. So, every time you want to find out the angle, you use the Cartesian. So, use Cartesian equation to work out angle. Right, that's the usual idea. So how do I get the Cartesian equation? You make t the subject, so t equals to x over 200 cos alpha, and then you substitute that into y. So you get negative 5 x over 200 cos alpha squared plus 200 sine alpha times x over 200 cos alpha, and then you cancel things, 200, and then you're going to go negative 5 x squared over 4 and then 4 zeros cos square alpha, and then that will be x. Now the sine over cos become tan alpha, like that, and that equals to y. So that's your Cartesian equation. Now how do I use it to find angle? Because I know it passed through the point. Yep. Earlier. Yeah. Okay. So you need the point. So the point is it passed through this point here, 1,000, 2,000, 1,000. Right. So you substitute this point here. So you substitute x is 2,000, y is 1,000. Okay, substituting there you get an equation of alpha only. Alright, continuing. Alright, so we get 1,000 equal to negative 5 times 2,000 squared over 40,000 cos square alpha plus 2,000 tan alpha. Okay, so I substituted x into there and then y into there. Okay, now you have to simplify, so you just have to use your calculator. Okay, so you're going to simplify this, and I use my calculator to do that. So you get 2,000 squared divided by times by negative 5 times by 5 divided by 40,000. Oh, I forgot to square. Yep, you're right. 500. So negative 500. So you get negative 500 over cos square alpha plus 2,000 tan alpha. So now there's only alpha in the equation. There's no other variable. And then you have to keep simplifying. Maybe you can write cos square, 1 over cos square as sec square. Plus 2,000 tan alpha. So it's quite a lot of work. and then divide everything by 500. So divide both sides by 500. That will get rid of a lot of things. So you get 2 equals to negative sec squared alpha plus 4, right? Tan alpha. Right, so we have to solve this trigonometric equation. Now, how do I solve it? You have to change sec squared into tan squared. Now, how do I change sec squared to tan squared? You can use you can use a formula which is not on the reference sheet, so you have to remember what it is. So the equation is sec squared equals to 1 plus tan squared. Alright, so we're going to change it to 1 plus tan squared alpha plus 4 tan alpha. Like this. And then you just expand, so you get negative 1 minus tan squared alpha plus 4 tan alpha. And then you move all terms to the left side. Minus 4 tan alpha plus 3, which is a quadratic equation in tan alpha. Okay? Alright, so have a think. So I put it all here, so you can still see. Okay. Alright, so we'll try to solve this. So find out what tan alpha is and then find out the angle. And show that there are 2 possible angles. You will hit the fortress 2 kilometers away. Okay, so let's find the angle. So it's like a quadratic, so you can factorize it. So you go tan alpha minus 3, tan alpha minus 1, which means that tan alpha is equal to 3 or tan alpha equal to 1. And then to find alpha, you just go tan inverse of 3. These are all going to be in the first quadrant because alpha is acute when you throw things in the air. Alright, so you will get 45 degree in degree mode. And let's work out the other angle, which you go shift tan 3, which is maybe around to the nearest minutes. 34 minutes. 71:34. 71:34 minutes. Okay, so you got these 2 angles. I think that's all you have to do for this question. Maybe I could move things across. Alright, let me try to move things. Maybe I can move this bit. Does it fit there? Doesn't fit. Well, maybe this bit fit. This bit fit. Still too big. Still too messy. Okay, I'll just leave it there. Okay. Alright, okay. Good. Alright, so any question? Any question? No question? Okay, good. Alright, we found the 2 angles. Actually, let's move it back. Okay, good. Alright, so now we're going to maybe illustrate this on a diagram. So on the diagram, you see that there's 2 possible angles that you can hit the fortress 2 kilometers away. So you go, the first one is 45 degrees, which go like this. And then there's another one which is 71 degrees, which I could use a different color pen, which also hit that fortress 2 kilometers away. So 71 degrees, okay? All right, good. So there's 2 possible angles. And now we're going to work out on part B the corresponding flight times and the impact speed and angles. Okay, so we have to find out how long it takes to get there. Okay, so what we do is we do it by 2 cases. The first case is where alpha is 45 degrees. Right? Okay, so let's update our formula. So flight times. So let's write down the equation. So what was the equation? The 6 equations are these 2. So let's write them all down. 200 cos alpha, 200 cos alpha t. Okay, and then we got y dot x dot. Okay, let's write them all down again. Okay, so the equation was x dot equal to 200 cos alpha, x equal to 200 cos alpha t, and then we're going to keep going. So y dot equal to negative 10t plus 200 sine alpha. Okay, all right, sine alpha, and then y equal to negative 5t squared plus 200 sine alpha t. Okay, good. So now we have to update it with 45 degrees substituted. So we substitute 45. So x dot equal to cos 200 cos 45 cos 45, and that's going to become 200 over root 2, which is 100 root 2 if you rationalize. And then x will now be 200 root 2t. Okay, so let's put a box around them, which I will use later on. And then same thing for y dot. Y dot will be, what will y dot be? Negative 10t plus 200 times sine 45. Sine 45 is 1 on root 2, which simplifies to be 100 root 2. Okay, and then same for y. Y will be negative 5t squared plus 100 root 2t. Okay, so we've got these 4 equations, which we'll use to answer the question. Okay, so we're going to find the flight time. How do I find the flight time? To find the flight time, we know that the position, the x value, you reach the top of the mountain when x is 2,000 meters, right? So we have to find the t. So I could just use this equation when x is 2,000, or you can use this one where y equal to 1,000. You can find out what t is, but this is much harder to solve. So it's better to use the x equation. So when substitute 2,000, you have to find the time. So let's find the time. So you go 2,000 equals to 200 root 2t. So therefore, oh no, that should be 100. Oops, sorry, 100 root 2t. And then you're going to write down, so therefore t equal to 2,000 over 100 root 2. And that gives you the time it takes to reach the top of the mountain. Yep. Yep. Yeah, not necessary, because the reason I wrote it, I need to find the impact speed. And to find the impact speed, you have to go y dot. You have to do that. That's why I write both. Yeah. And then also the angle, you have to go tan inverse of y dot over x dot equal to theta. Okay, so we'll use it later on. So we'll just get prepared ourselves for the later part of the question. So let's continue. So we can simplify, which is 20 over root 2, which is cancel, you get 10 root 2 seconds. So take 10 root 2 seconds to reach the top of the mountain. And we've got the time now. Once you got the time, we need to use it to find the speed. Okay, so let's work out the speed. So we substitute this time into both x dot and y dot. So x dot is the constant. So let's work out the impact speed. So you go x dot, which is just 100 root 2, but y dot equals to, you have to substitute t equal to 10 root 2. Yep, t equal to 10 root 2. Substitute that in, so you get negative 10 times 10 root 2 plus 100 root 2. Oh, which they cancel, which comes 0. Okay, so you reach maximum height when you reach the top of the mountain. So 100. So therefore, the actual speed, so if, well, since y dot is 0, then the actual speed must be, impact speed must be equal to x dot, which is same as 100 root 2 meters per second. Okay? And to find the angle, because y dot is 0, therefore impact angle must be 0. That's the impact angle. Alright, like that. Alright, so that was pretty quick. Okay, now once we're done, then we have to do case 2, where the angle is 71 degrees and 35 minutes. So 71 and 35, 71, 35, 34. 71, 34. Okay, so 71, 34 minutes. Okay, so if you substitute that into the equation, let's go back to this one. X dot equal to 200 cos alpha. And you have to go 200 cos 71 degrees 34 minutes. If you do that on your calculator, you will get 200 cos answer. You get 63 point something, 63.25 approximately, right, which is not an exact answer. So how do I overcome this? So we want to be an exact form. So to get the exact form, instead of using alpha, we know alpha comes from tan alpha equal to 3. So in that way, it will be better to use this right angle triangle, and 3 over 1, so it's root 10. So therefore, cos alpha is 1 over root 10. That will be a much better form to write in. So let's change the x dot. X dot will be equal to 200 over root 10, which is just equal to 200 root 10 over 10, so 20 root 10. Okay? And then once you got x dot, you can find x, which is 20 root 10 t. Alright, so draw a box around it. So when you don't have the exact angle, you use the tan alpha equal to 3, the original answer, to work out the other two ratio without finding the actual angle. And the same thing for y dot. So y dot is negative 10t plus sine 200 sine alpha. And from the triangle, sine alpha is 3 over root 10, which you can simplify, which is negative 10t times by that, you get 20 root 3, so 60 root 10. That's y dot, and then y is negative 5t squared plus 60 root 10t. Okay, so draw a box around it. And then we're going to answer the flight time and the impact speed. All right, have a try to find out the flight time. And once you get the flight time, you can work out the impact speed. Okay, yeah. And then we use the fact that you reach a mountain that's 2,000 kilometers, 2,000 meters away. Find t. Okay, use this equation. Okay. And once you get the time, substitute back to find x dot and y dot to work out impact speed and angle. Okay. Alright, so let's make this a bit bigger. Think about this. Alright, good, all done. Have a try. Alright, let's continue. So we go like this. Alright, let's try to solve it. So you get 200, 2000 equal to 220 root 10 t. So t equal to 2000 over 20 root 10. Simplify, that will be 100 over root 10, which is 100 root 10 over 10, 10 root 10 seconds. Now let's compare the two flight times. So this is 10 root 2, that's 10 root 10. So obviously that takes longer to reach the top because it seems that you have to travel longer to get there, right? So that takes 10 root 10 seconds. That takes 10 root 2 seconds as expected. Okay, all right. So that's a flat time. And once we got the flight time, we can substitute back to find x dot, which is a constant, 20 root 10. And then the y dot, which is going to be, you have to substitute t equal to 10 root 10. So you get y dot will be negative 10 times 10 root 10 plus 60 root 10. So you get negative 40 root 10. Okay, and then work out v. Now v equals to square root of x dot square plus y dot square. So you get 20 root 10 square plus 40 root 10 square on negative 40 root 10 square. And then use your calculator to work out the speed. Okay, so what's the speed? So you get 20, so you get 400 times 10 plus 1600 times 10. 20,000. So 100 root 2, isn't it? So you get 100 root 2 meters per second. Alright, that's the impact speed. And to get the impact angle, you just go tan theta equal to y dot over x dot. And y dot will be negative 40 over root 10 over 20 root 10. And then you get negative 2. So if you do that on a calculator, shift tan negative 2 gives you negative 63 degrees, 63.4. So theta is approximately negative 63.4 degrees. So that's the impact angle. And in terms of the diagram, you go back to the diagram, which I will show you. So the impact angle will be equals to 63.4 degrees. Okay. Right, all done. So we're going to do more calculations. So I'm going to show this page again, just in case you still haven't got it down. Okay, good. All right, and then we'll go to the next page when you're ready. Hopefully all done. Okay, so we're going to go through how to derive these equations, the general equation for projectile motion. These equations are not to be memorized, so we'll just derive the general formula. So in general, it started with x double dot equal to 0, y double dot equal to negative g, and it goes like this, and the initial angle theta with initial velocity v, right? So we want to derive the sixth equation again. It's like before, when t is 0, x and y are both 0. X dot equal to v cos theta, y dot equal to v sine theta. Okay, and that will help you to find c. So when you do x dot equal to c, when t is 0, x dot equal to v cos alpha, or cos theta, so you get x dot equal to v cos theta. Okay, you can do the same calculation to get x, which is v cos theta t. Alright, well, I skipped the details, so you got these three equations over here. And similarly, you can get the three equations for y. So y dot equal to negative gt plus c when t is 0, y dot equal to v sine theta, which you will get c equals to v sine theta. Okay, and then you can do y to get negative half gt squared plus v sine theta t. Okay, so we got these six equations. I skipped some details. Alright, these are not to be memorized. These are just in general form, okay, in terms of the per numeral. Okay, so we're going to use this equation to work out the maximum height, the time it takes to reach the maximum height, and the time of flight. Okay, so we're going to use these 6 equations like we did before. So we have a general formula. Okay, so we've got these 3, these 6, and then we're going to find the time it takes to reach the maximum height. So time to reach the maximum height is y dot equal to 0. And then find t. Okay, have a try. Alright, so okay, let's do that. So y dot is 0, so do y dot equal to 0 means that negative gt plus v sine theta equal to 0. Make t the subject, so you get gt equal to v sine theta, t equal to v sine theta over g. So the answers are on the top, and to differentiate from the variable time, we'll call the the time to reach maximum height capital T. Actually, I'll use the same T. Let's write TH, the time it takes to reach the maximum height. Okay, so that's the derivation. And once you get the time to reach the maximum height, we can find the maximum height reached by substituting this into y. Y equal, okay? So y equal to negative half gt squared plus v sine theta t. So you substitute that in there and simplify. Hopefully you get the maximum height to be this expression. So let's try to do this. So y is now maximum height equal to negative half g. Substitute v sine theta over g squared plus v sine theta times v sine theta over g. Like that. And then we simplify, that will be negative gv squared sine squared theta over 2g squared plus v squared sine squared theta over g. Okay? And then the g squared will cancel, and you find out they are like terms. So if you just multiply top and bottom by 2, and you end up getting, you will have the same denominator, 2g negative v squared sine squared theta plus 2v squared sine squared theta. They are like terms, so therefore become v squared sine squared theta over 2g. That's the maximum height. Okay? Alright, so some algebra involved. So you are expected to know how to prove these formulas, because often in the exam they say find the maximum height reached in terms of theta and g. So you need to know how to do this. Okay? Alright. Once you get the maximum height, the question is, what angle should I project to reach the highest value of maximum height? So what's the maximum value of this? What angle should I throw? Well, what's the maximum value of sine theta? 1, yeah. So therefore, max value of sine theta is 1, and that occurs when theta is 90, right? Because sine 90 is 1, and that's intuitively true. So if you want something to throw as high as you want, you throw vertically up, right? You wouldn't throw it at an angle. So therefore, if you substitute that in, the maximum you can ever get is when you throw vertically up will be sine 90 squared, which is 1. And sine 90 is 1, therefore you become v squared over 2g. That's the maximum value of the maximum height that you can get. Right, I need this expression. Let's draw a box around it. Okay, next we're going to find the time of flight. So to get time of flight is to make y equal to 0. Right, y equal to 0. Now go back to the equation for y equals to negative half gt squared plus v sine theta t. Make that equal to 0, we are going to find t. Now how do I find t? It's a quadratic equation, so t is a common factor. So you get negative half gt plus v sine theta equal to 0. So either t is 0, which is okay because at the t is 0, y is 0, it's on the ground. It's also on the ground when this is 0. And that's where you find the time of flight. So you make t the subject. So you go half gt equals to v sine theta. And then make t the subject, so t must be 2v sine theta over g. And we'll call that time of flight capital T. Draw a box around it. And notice that due to the symmetry, the time of flight is exactly double the time it takes to reach the highest point. Note that this is double the other one. So note, this is double the time it takes to reach max height. Alright. Okay, done. What else are there? Time of flight. Then we'll go to the next page. Again, we're interested in, well, let's find the range. We've got the maximum height. Let's find the range. And how do I get the range? We substitute that into find x. So the time of flight being 2v sine theta over g, x equal to v cos theta t. So we substitute that in here to find the range. So the range is r, how far you reach the ground. So you write v sine cos theta times 2v sine theta over g. Like that. V squared, so you get v squared 2 sine theta cos theta over g. And hopefully you remember the trigonometric formula that you learned before. This is the double angle formula for sine, so you get sine 2 theta. So you get a more simplified expression. That's the formula for the range. And the next question will ask, what angle should I choose so that it can be thrown as far as possible? Yep, how do we know it's 45? That's when, so if I write R max, what's the maximum value of R? What angle? That's when sine 2 theta must be 1, right? That's the maximum value of sine. And that occurs when 2 theta is 90, because sine 90 is 1. Therefore, theta must be 45 degrees. That's why 45 degrees will result in the maximum angle. So let's substitute 45 in there. So you get v squared sine 2 times 45 over g. And sine 2 times 45 is sine 90. And sine 90 is 1. So the maximum value of the range is this. Okay. All right, good. So we got that. What else what to do? So we're going to draw some path for different angles. And this is done below, and then we've got this one, we've got that. Okay. All right, good. Okay, let's continue after you finish this. Let's do various paths. Okay, so basically, this is 45 degrees. This is 45. If it's 45 degrees, you will reach v squared over g, right? Now, if I throw things vertically up at an angle theta is 90 degrees, you throw vertically up. And the highest is going to be, okay, good. I forgot, what was it again? V squared over 2g, right? The maximum value is v squared over 2g. So v squared, is it to scale? Okay, yeah, it should be. So v squared over 2g. So when you throw things vertically up, the highest you can ever reach is half of the range, isn't it? Right? Because that's v squared over g, that's half of the total. So that's the highest you could ever reach when you throw 90 degrees. So let's label it there. So v squared over 2g. Okay, v squared over 2g. That's when you throw things vertically up. Throw vertically up. Alright, so what else I have to say? Okay. Right, okay, good. Now let's work out what the maximum height is. Maximum height, that occurs when the expression for maximum height is v squared sine squared theta over g, and we're going to substitute theta is 45 degrees. If you substitute that in there, you will get sine square 45, and sine 45 1 on root 2. So you're going to square 1 on root 2, so you get v squared over g times 1 on root 2 square, which is v squared on 2g. Okay, so v squared on 2, actually that has a 2 at the bottom, I think. Yes, so it will be v squared over 4g. So v squared over 4g is exactly half of the highest value you can get. So that's the diagram. Let me use a dotted line tools. Okay, alright, so that will work in blue, green pen maybe. Okay, alright, so let's go like this. So we've been decorating with the diagram. Okay, alright, good. Okay, that looks good now. Okay, good. What else I want to say? Okay, good. So the next thing we're going to do is, what if I put theta as 30? So let's put 30 there. Now, remember the formula for maximum height is v squared over sine squared theta over 2g. Okay, so let's substitute 30 into the expression. So we get sine h is v squared sine 30 squared over 2g. If we simplify that, sine 30 is half, you get v squared over times a quarter. So you get v squared over 8g. That's the maximum height at 30 degrees. Let's work out the range. The formula for range is v squared sine 2 theta over g, and then you put 30 degrees, you get v squared sine 60 over g. Sine 60 is root 3 over 2. Yes. So you get v squared root 3 over 2. Okay, yep. Okay, good. So you write it down, v squared over root 3 over 2g. Okay, so let's fill in this information. Again, we see it on the diagram. Okay, so let's do that. So on this diagram, you will see that this is the range, and we're going to go with 30 degrees. And you reach a maximum height of v squared over 8g, and that's to the maximum height. So go like this. Okay, so that's 30 degrees. 30 degrees. Okay, yep. And I want to do the same with 60. Find the maximum height and the range. Okay, do the same thing for maximum height and the range. So do the same thing, h equal to v squared sine 60 squared over 2g, and you will end up getting 3v squared over 8g. Okay, which happens to be this number here. Okay, 3v squared over 8g. Okay. And then the range can also be found, r equal to v squared sine 120 over 2g. And if you do that, that will still be v squared root 3 over 2g. So they get the same range, but different maximum height, right? The maximum height is higher, but the range is the same. Okay, good. So let's do this. So we're going to label the other one. So it's going to reach here, going to here, and here, actually over here. So we're going to go this. Okay, so that angle is theta equal to 60. Okay, so you notice that with two different angles, they have the same range. Okay, they have the same range with these two angles. And in fact, this is generally true that if the angles are complementary to each other, the range will be the same. So note 30 and 60 are complementary angles. And if the angles are complementary, the range will be equal. Okay? I can prove it's true for general, that it doesn't have to be 30 and 60, that if you pick any angle, so let's try to prove this rule. So let's try to prove, so if the theta is alpha, so if theta equal to alpha, the range will be v squared sine 2 alpha over g. So if you pick a complementary angle, they should have the same range. So let's prove it. V squared sine 2 times 90 minus alpha over g. Okay, so if you expand this, you get v squared sine 180 minus 2 alpha. And we'll know from trigonometry, sine 180 minus 2 alpha is just sine 2 alpha. Okay, which is same as before. Let's call this 2. This is R1, this is R2. R1 equal to R2, right? Okay, so we'll prove it's true in general. Yeah. Yeah, you could. Yeah, that's not very hard. You just substitute 90 minus alpha, 180 minus 2 alpha. Sine of this is that. So you should learn all the proofs. So the harder question, you will involve this sort of proof. So make sure you learn this. Okay. I think that's all. Oh, actually, we'll have more. Okay, so we'll have to continue. Okay. Let's get the Cartesian equation. Hopefully you're ready. Get the Cartesian equation. So go to next page. Now x equal to v cos theta t, y equal to v sine, y equal to negative half gt squared plus v sine theta t. So we substitute. So to get the Cartesian, we'll make t the subject. T equal to x over v cos theta. Substitute into equation y. Okay, so write y equal to negative half g x over v cos theta squared plus v sine theta x over v cos theta. And then you're going to simplify this, which is equal to negative gx squared over 2v squared cos squared theta plus the v gets cancelled, which you end up getting tan theta x tan theta. Okay, and now we got it because the 1 over cos squared is sec squared. So you write x tan theta minus gx squared over 2v squared sec squared theta, because the sec squared theta equal to 1 over cos squared theta. One theta equal to 1 over cos squared theta. Okay, good. So we got the Cartesian equation. Now, the next thing is, I want you to use the Cartesian equation to find the maximum height. We can also use this to find the maximum height, even if we... Okay, yep. So how do I find the maximum height? That occurs when the derivative dy dx is 0. Okay, let's do that. So differentiate this. So this is the equation of the parabola. So we're going to differentiate this and find the maximum height. Let's try to do this. Okay, so we're going to differentiate dy over dx equal to tan theta, because differentiate x is 1. Differentiate x squared, you get 2x, so you get negative gx 2x sec squared theta over 2v squared, right? And then you're going to make that equal to 0 to find out what the x is. So what will x be? X is going to be tan theta equals to gx sec squared theta over v squared. And then x is going to be v squared tan theta over g sec squared theta. Okay, and then we're going to simplify this, which is v squared over g times tan theta. So 1 over sec squared theta is cos squared theta, and that will cancel with tan theta. So you get v squared over g times sine over cos times cos squared theta. That will cancel. You'll get this. Okay, good. So you end up getting sine theta cos theta over g. Okay, and then after that, you have to substitute that into y. Actually, take longer than I thought. Okay, good. So after this, you substitute this to find y. So substitute x equal to this thing, and then you get y. And hopefully eventually you get the maximum height, which is v squared sine squared theta over 2g. As you can see, this is not a good way to find maximum height because the equation gets very complicated. So an easier way to find maximum height is always do, so the easiest way is find y dot equal to 0 and find t. Once you find t, find y. If you use the Cartesian form, it gets very messy. So it's not a recommended way to do it, but it's quite algebraically challenging. So you have to go through the detail. Okay, I'll leave that detail to you. And then finally, we can also get the range from the Cartesian form. Just make y equal to 0 and solve this equation. X tan theta minus gx squared sec squared theta over 2v squared. Okay, and then you just solve for x. X tan theta minus gx sec squared theta over 2v squared. So either x is 0, and the other one, if you solve it, equal to 0. If you solve for x, you should get the range. Alright, let's finish that off. So you get gx sec squared theta over 2v squared equal to tan theta. And then you're going to make x the subject, x equal to 2v squared tan theta over g sec squared theta. And like before, these two will cancel. You get sine theta cos theta, 2v squared over g. So therefore r equal to v squared sine 2 theta as expected, which is very long. Again, this is not a recommended way to find the range from the Cartesian form. Okay, so note this is longer than the other method. Okay, alright, so the Cartesian form is best to find the missing angle. Okay, so if you use it to find other things like maximum height and range, it takes too long. I think I spoke long enough, so maybe I'll just stop there. And tomorrow we're going to go through some HSC questions. Alright, so let's finish that. Okay, good.